Level 4, we're going to be graphing secant, cosecant, and cotangent functions. Remember that cosecant is the reciprocal of sine. So if I take any y value on my sine graph and I find its reciprocal, that's going to be a point on my cosecant graph. So let's start at the origin. My sine graph has the point 0, 0. The reciprocal of 0, if I do 1 over 0, I get undefined. So at the on the y-axis, I'm going to have an asymptote for cosecant. Then if we think about pi over 2, I have the point pi over 2, 1. So my y value here is 1. If I take the reciprocal of 1, if I 1 over 1, I flip it, I still get 1. So at pi over 2, I'm going to have a point at 1. And I didn't label my axis. 1, 2, 3. Negative 1, negative 2, negative 3. Okay. Now at pi, I'm back to a y value of 0. The reciprocal of 0 is undefined, so I'm going to have another asymptote. At negative 3 pi over 2, the y value is negative 1. The reciprocal of negative 1 is negative 1. So I would have a point right here. At pi over 2, we have a y value of 0. The reciprocal is 0. So anywhere I have a 0 or an x-intercept on my sine graph, I'm going to have an asymptote for my cosecant graph. At negative pi over 2, I have a point at negative 1, so the reciprocal is negative 1. And then at negative 3 pi over 2, we would have a point at 1. Now, the question is what happens in between there. So let's think about what happens at, say, pi over 4. Pi over 4 is halfway between 0 and pi over 2, so about right here. The value of that function, if we think about our unit circle, sine of pi over 4 is root 2 over 2. If I take the reciprocal of that, the reciprocal of root 2 over 2, if I flip it, I get 2 over root 2 multiplied by root 2 over root 2. We get 2 root 2 over 2, which is root 2. And that is about 1.4. So we get something that is up higher. And what's going to happen is you're going to get a U-shaped graph right there. And the bottom of the U is going to be at 1, and it goes up and approaches the asymptotes on the other side. And when you have your point at negative 1, you're going to have an upside down U. So this cosecant graph has a bunch of U's and upside down U's. And the only points that I'm going to require you to plot are the points at positive and negative 1. And then you just have to draw the shape of the U. So my suggestion for graphing these is to graph your sine curve. So you could go ahead and graph the function sine of x. And anywhere that you have an x-intercept, make an asymptote. Anywhere that you have the top of a mountain, make that your point, and then draw the U that goes with it. And then you can go back and erase the sine graph because that's not actually part of this graph. But it can be your guide to graph your cosecant graph. For the domain of this function, it has a lot of missing values because we have a lot of asymptotes. So we could say all real numbers, but x cannot equal, it can't equal 0, pi, 2 pi, negative pi, negative 2 pi, any multiple of pi. So it cannot equal pi k, where k is some integer. The range of this function, it does go down forever, it does go up forever, but it never equals anything between -1 and 1. So the range of this function is going to be negative infinity to -1 with a bracket union +1 to infinity. The period is going to be the same as the sine period, 2 pi. The amplitude, it doesn't really have amplitude specifically, but if there's a 1 in front, that means your point that you draw is up 1. If you had a 2 in front, that point would be up at 2. The asymptotes occur at x equals we have x equals 0, x equals pi, x equals 2 pi, and so on. So we can just say x equals pi k, and that would cover all our asymptotes. The x-intercepts, it has none, and it has no y-intercepts. And there's your cosecant graph. To graph the secant function, it's the reciprocal of cosine. So what you should do is lightly graph the cosine function, and then graph your secant function and erase your cosine function. So I'm going to start by graphing the cosine function. Its first point is on the y-axis up 1 unit. Next I would go down to pi over 2, 0. Then I go down to -1, back to 0, back up to 1. And then going in the other direction, we get this graph. And so this is my cosine graph. Now I'm going to be erasing that because I'll go in a different color now and graph my secant function. Just like we did with cosecant, anywhere that you have a point at 0, when I do the reciprocal, it's going to be undefined. So those are going to become asymptotes. So anywhere the graph has an x-intercept, turn it into an asymptote. Anywhere you have the top of a mountain or the bottom of a valley, that's going to be the starting point for your u. So I'm going to keep that point. If it's a mountain top, I make it a u going up. If it's the bottom of a valley, I make it a u going down. So we get something like this. And now I'm going to go back and erase my red graph and just leave myself with the secant graph. And there it is. The domain of this function is all real numbers, but x cannot equal, it can't equal pi over 2, and then if I add 2 to, or add pi to that, I get 3 pi over 2, can't equal that. Add another pi, you get another value it can't equal. So I'm going to say it cannot equal pi over 2 plus pi k, because that's where my asymptotes occur. And then the range of this graph, just like with cosecant, is going to be parenthesis negative infinity to -1 bracket union 1 to infinity. The period is 2 pi, same as a cosine graph. The asymptotes occur at x equals pi over 2 plus pi k. So at pi over 2 plus or minus any multiple of pi. The x-intercepts, there are none, and this one does have a y-intercept at 0, 1. And that's the cosecant graph. Finally, we are going to graph our cotangent function. Cotangent is the reciprocal of tangent. So anywhere that tangent had an x-intercept, cotangent is going to be undefined because the reciprocal of 0 is undefined. So I'm going to have an asymptote on the y-axis. I'm going to have an asymptote at pi, another one at 2 pi, negative pi, negative 2 pi, and so on. And the places where I had asymptotes in my tangent graph are going to be x-intercepts in my cotangent graph. So I had an asymptote at negative pi over 2. Now I'm going to have a 0 or an x-intercept at negative pi over 2. And negative 3 pi over 2, and pi over 2, and 3 pi over 2. And if we take the reciprocal of some of our tangent values, so think of, go back to our tangent graph, at pi over 4, we have the point 1, 1. The reciprocal of 1 is 1, so at pi over 4 on our cotangent graph, we're still going to have a point up 1. At 3 pi over 4, we have a point with a y value of negative 1. The reciprocal of negative 1 is negative 1. So at 3 pi over 4 on our cotangent graph, we're still going to have a point at negative 1. And we end up with a function that looks pretty similar to the tangent graph, but the curve is decreasing instead of increasing, and it's sort of shifted to the side compared with the tangent graph. So that same graph would repeat in all of these sections, and this is your cotangent graph. The domain of this graph is x can be anything except where we have asymptotes, so all real numbers, but x cannot equal any multiple of pi, so pi k. The range of this function is negative infinity to infinity. Y can be anything. The period is, just like with tangent, we did pi over b, so the period is pi, same as a tangent graph, not 2 pi like cosine and sine. The asymptotes occur at x equals any multiple of pi, so pi k. It doesn't have amplitude, but remember that point, if you have a 1 in front, then we have these points that are up 1 and down 1. If we had a different number, say a 2 in front, they would be up 2, down 2, and so on. The x-intercepts occur at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2. The spacing between them, they're pi apart. So I pick one that I start with, like pi over 2, and add any multiple of pi to it, so pi over 2 plus pi k would be the x-intercepts, and this has no y-intercept because we have an asymptote on the y-axis. And that is your cotangent graph.